really is a pleasure to welcome you all here this evening. This is the third lecture, climate lecture in 2025, the first one in person. We've had two online, so we're keen to keep the element of in-person going because it's the chats and meeting people before and afterwards that is so valuable in addition to the public lecture itself. So as many of you will know, we have a national objective to transition to a climate neutral and climate resilient society by 2050. And that is going to be a complex and challenging issue ahead of us that will require the collective effort of many, many stakeholders, government, business, communities, and individuals. And so as part of addressing that challenge, the government and the Department of Climate, Energy and Environment established the National Dialogue on Climate Action, and that was to bring in that broader cohort of stakeholders and empower climate action across Ireland. And the EPA were given the job to facilitate the dialogue, and our climate lectures are a really important aspect of the work that we do on the dialogue. Of course, the climate lectures have been going for a long time, since 2007, so nearly 20 years. And we have explored many different topics over those years, bringing leading scientists here, decision makers, influential voices, and really driving that exchange, reflection, and cross-disciplinary collaboration. And we've covered a wide variety of topics from ocean circulation, health impacts, finance, communication, and evolved what we're talking about as the climate agenda has evolved over those years to more recently talking about transformative change, climate justice, adaptation strategies, and the role of institutions in shifting from paralysis to pragmatism. So as I say, we had two lectures already in 2025. This is our third lecture. What remains consistent through the climate lectures is the audience, the energy and enthusiasm of the audience, the lively discussion that we have afterwards through the Q&A session, and I'm sure we will have the same level of engagement this evening and looking forward to it. So I'm delighted to welcome our speaker, Professor Nadia Pinardi, who is presenting on the important topic of coasts at risk, building stronger communities. Professor Pinardi holds a Ph.D. in applied physics from Harvard University, and she is a Professor of Oceanography at the University of Bologna. Her research interests span a wide range of topics, including ocean numerical modelling and predictions, data assimilation, numerical modelling of marine physical biological interactions, and the dynamics of pollutants in marine environments. And among her key contributions is the conceptualization and successful implementation of ocean forecasting systems across various global regions. In 2025, in recognition of her outstanding contributions to operational oceanography, she received the Prince Albert I Medal awarded from the International Association for the Physical Sciences of the Oceans. Professor Pinardi is a member of the European Academy of Sciences and the Scientific Council of the UNESCO Regional Bureau for Science and Culture in Europe, and she currently chairs the UN Decade of Ocean Science Programme CoastPredict and is the director of the UN Decade Collaborative Centre for Coastal Resilience. And from 2020 to 2024, she also served as co-chair of the first assessment on sea level rise in Europe. So she's more than qualified to come and talk to us here on this really important topic of coasts at risk. And it is really relevant to Ireland, to an island nation. Our Climate Change in the Irish Mind study, which looks at the behaviours and the attitudes of Irish people in relation to climate change, show that 9 in 10 people in Ireland believe climate change is already affecting our weather. Nationally, there are worries around severe storms, flooding, sea level rise, and our climate opinion maps show that those concerns are felt even more acutely in our coastal regions. There is strong support for climate action across Irish society. The public hold a high level of trust in scientific communication on climate change, so lectures like this are so important. And 9 in 10 people believe that Ireland has a responsibility to act on climate change, and we should do what we can here to reduce our own emissions, irrespective of our size. But unfortunately, the risks and the harms of climate change are still often seen as distant threats. Only about half of the Irish population believe that climate-related harm is happening now, while the rest see those impacts as something that will occur a decade or more into the future. So our work is always continuing in terms of building that awareness, building that understanding of climate and its impacts. So in tonight's lecture, Professor Pinardi will explore how building resilience means more than just reacting. It requires proactive systems that prioritise human safety and adaptation strategies that address the unique challenges climate change brings to our coasts. So I very much look forward to hearing the lecture and hearing the Q&A afterwards. And I'm going to hand over now to our moderator for the evening, Lara Duggan.
Thank you so much, Emer, for that lovely introduction. I won't keep you long, just a couple of very quick housekeeping things before we get started. So my name is Dr. Lara Dungan, and it's my absolute pleasure to be your chairperson here this evening. I just wanted to welcome you all to the lovely banking hall here in the College Green Hotel, and especially to our speaker, Professor Pinardi, who will be talking to us now in a moment. Just to let you know, there will be a Q&A at the end, as there always is. So if you could just raise your hand, please, if you have a question, and just wait for the microphone to come. Just so that everybody can hear and for the recording as well. Just a couple of little housekeeping announcements. Just please take note of where the emergency exits are. Just make sure, please, your mobile phone is on silent. We're very happy for it to be turned on, for you to continue to talk about our wonderful lecture. But just if you could keep it on silent, we'd really appreciate it. And just if you could remain seated throughout the duration of the lecture, we'd greatly appreciate it. So the lecture and Q&A are being recorded by the EPA. The material will be made available on the EPA Ireland YouTube channel, along with the many recordings of the previous lectures. So please feel free to have a look at all of those. This will be available after the event, and it may be used for future EPA communication. So just to be aware of that if you're asking a question. Okay, so I'd just now, without further ado, like to welcome Professor Nadia Pinardi to the stage.
Thank you very much. In particular, your EPA for this wonderful initiative. I would love to have the same kind of initiative in Italy. Unfortunately, we don't. We have it once in a while. And this is really important for building stronger communities to face the challenges of the future. So, your system components, we know them. We try to schematize them into 4 spheres. And as you can see, the oceans are, you see the colors indicate the danger growing for all these quantities in the different spheres. And global surface temperature, global sea level, ocean heat content are among the ones that are most important for our climate action, to assess, to evaluate all the time. So oceans are the center of the impacts of climate change. Just to give you some numbers, we have from 1900 to 2015 about 1 big devastating storm surge event every year. We have 172 million people affected and almost 1 million fatalities. So this is, seen in comparison to a war, might seem little, but still it's a large number. And since we might prevent this to happen, it is our, we need to do something about this. So this is a beautiful picture, in my opinion, this recent work in 2018. How much will the 100-year sea level extreme, which means a very unusual extreme, occur in our coastal areas in 2100. So it means that you see the scale here. The scale is here. And I want to point out the 10 years here and the 1 year here. This picture shows that in the red areas, the 100-year sea level extreme will occur every year. And in our region, it will occur every 10 years. Well, it's a big risk. And, finding how the society can react to this risk and to this, actually, in this case, is still hazard, is difficult. But we know this is very likely to occur. So how do we prepare? This is the question that scientists have been more and more engaged to give an answer. We have be sure the science community understand this important topic, and they are ready to be engaged. So what do we have? What is coastal resilience? We like this idea. Sorry, it shouldn't have appeared this way, but it's almost correct. So it is a framework, a concept that overviews some important action, multidisciplinary actions, multi-hazard actions. So coastal resilience is the right word that encompass our effort into the future. It means that we have to construct a system that has the ability to come back after a big disturbance has occurred. And, this is not easy, right? It has to restore its essential functions. Maybe it has, it is impacted, but then something can go back where it was. Let's see. Yeah. So this is the part that should have appeared now. So in order to be ready for resilience, this is the word that the United Nations use to qualify the actions. We need to have at least the 6 issues treated here: the assessment, the planning, the prevention and protection, preparedness, response, and recovery. Now, clearly, my part is to inspire and to try to drive a science-based assessment, a science-based planning, and a science-based prevention and protection. The rest, hopefully, will be done by working together with the collective intelligence, what I call the collective intelligence, that is so important for resilience. So what is the difficulty? The difficulty is that we have to embrace a multi-hazard approach. So we need to look at, let's say, tsunamis. You don't have to, sorry, I should go here. Tsunamis, landslides, subsidence you have, biological harmful algal blooms, cyclones and storms, sea level rise, anthropogenic urbanization pressures, for example, and ecological wetland degradation. So we need to see all that in order to find the right solution. It's a daunting endeavor. And this is why we need so much a scientific approach to find a way schematized somehow. But we cannot reduce the problem. So the reductionist approach that has guided science practically from Newton, it's not working anymore for climate. At least this is my thinking. So to enhance coastal resilience, we must prepare ahead of time. And in our UN Decade work, we had a big group saying, what are the pillars of being prepared? We need to design people-centered, multi-hazard early warning systems, and we need to design adaptation plans, define strategies that are useful for the long-term trends. So it's pretty complicated. both of them. And I'll show you where we are now. One big part was the knowledge hub on the sea level rise, but not only. So in the multi-hazard early warning systems, we have 3 parts: risk assessment, risk reduction, and the institution governance and social transformation that has to occur to help all that to really achieve resilience. And so there are many subsystems there that we need to prepare. Most of them are science-based. The other, for adaptation planning, we need, again, and especially for climate, co-develop with coastal communities, know what is that they think is happening. We need, and this is really new, high-fidelity modeling tools and systematic validation. Maybe, you always have seen, and it's an enormous effort, human effort, the IPCC. But, only now we can validate the models. We have tried to give an answer without being completely sure. That's why IPCC is so important, because they calibrate the way they say if things are becoming worse. They calibrate that language to be as close as possible to truth. But we have now, only now, the systematic validation. Why? Because we have 50 years of data, and especially satellite data. Systematic translation of information for policymakers. Yes, that's fundamental. Okay, so how then, let me see if I missed something. Yes, so in my talk, I will concentrate now on one particular theme, that is sea level change. It is a passion of myself to look at sea level change. First, because it's scientifically very intriguing, and second, because out of this, we can get examples that work also for other quantities. So causes of local sea level change are land motion, and I will not talk about that this evening with you. And but what I will talk about somehow is changes in ocean currents. They will change how much water is here. That means the sea level. And the shift in storms, tidal amplitude, and other natural changes will all affect the sea level. And then clearly, the melting glaciers, that is a very important impact that you have already clear, being so close to Greenland and the melting in Greenland glaciers. So what all this, is only for the sea level, and then there are impacts of this change in sea level on all the other compartments of the coastal environment, which we listed before. Okay, so most important is how we measure this, right? Because we need to validate. And so what is our state of knowledge here? It is overviewed in this picture. It is the tide gauge stations that now are very refined. They have a radar that marks the height of the surface from the station. And so we need to intercalibrate with the old tide gauges were not done that way. So another point. But very much of importance is altimeters. So the radar this time is not near the water, but is up in the sky, and through what is called the range, which is the pulse that goes back and the time it takes for the pulse to come back, you get the surface of the ocean. And you can get it over the whole ocean. That's the key, not only in the stations. So this is a revolution, right? It started in, well, the real revolution as a science revolution started in 1978. But the first altimeter that really worked was 1992. So we have only 30 years of data for the sea level. Okay, so this is the problem. Okay, you have seen many facets of this. What is the plan of action now? So few years ago, we started to seriously scrutinize how to arrive at building communities that were stronger. And so our first aim was to engage stakeholders and assess the risk with science. And in 4 years, because you need to have so many communities together and you have to bring a lot of data to make sense for these communities, we finally presented as a joint initiative between JPI Oceans and JPI Climate that you see here. JPI Oceans and JPI Climate, where your government was very supportive of this work. So these are member states that support specific actions in addition to the EU part. And so it's very important because it's EU member-driven activity. So we are getting to the policymakers to decide that this was important. That's an important point. And we had this first assessment report on sea level rise. What is containing, first, is a joint initiative, I've already said. It connects research and policy experts. So we went very multidisciplinary, trying to discuss and see our nomenclature, how does it work, scientific and socioeconomic sea level trends, connect sea level trends to scientific and socioeconomic trends. The aims is still, but we are seeing how to do this, yet not clear, provide periodic regional assessments tailored to the European policy and stakeholder needs. And it requires Europe, I can tell you, because not any of us can do this, not only from scientists, clearly, but also from the governments. So the sensor report, which I left a few copies for you of the summary, contains a typical structure of an IPCC report, a summary for policymakers, and 5 chapters where we did show where we are in Europe and what is the way forward, because we have last two chapters that are adaptation measures and decision-making principles and governance context and challenges. Okay, so let's see now for each of some of these, what are the results? Let's start from the knowledge gaps. And we did this with large consultation of stakeholders. And our question was, how are your adaptation plans for sea level rise? And we asked, are they effective? Are they flexible enough? And this is the result that came from the survey. It was a questionnaire that we sent to people in addition to a workshop. inexistent, insufficient, neutral, effective, very effective. And the color is white when it is 50% of the respondents, they say it is effective, not very effective. So what we see here is that it's good to know that 0% of the European people have an effective, to a certain degree, plan, because you see 0 in the inexistent, but 50% say it is insufficient, that you might have guessed, but very effective, nobody. Okay, so then is it flexible enough? And we quantified what we meant with flexible without going too much into the details now. And this is also, I just wanted to, I forgot to say, also we differentiated between the different seas, North Sea, Mediterranean, Eastern Atlantic, you are here. Eastern Atlantic, and somewhat similar, except for you are most sure that is insufficient, more than other basins. So we did this for the basin, putting together all the stakeholders. Okay, we got what are the gaps? And here is interesting because I was talking with some of you before the meeting here, and I find exactly the same point. And here in this word cloud, you can see ecosystem management, scientists. These are scientists answering, this is government answering, okay? So they say we are missing ecosystem management. And the word is ecosystem, because ecosystem means biology, ecology, geology, physics, all together, right? Together with infrastructure. Okay, so, and what other interesting is urban planning. It's coming out from government because coasts are part of the urban planning. And so, okay. Scientists also think saltwater intrusion is important, but yeah, and I think they are right, but it didn't come out the same effect on the government. Last but not least, we asked what is the largest knowledge gap in sea level rise? And here again, I find something that I discussed with you before. Again, I see that regional projections are everybody's, they say, we can't. What it means is that the projections that you will see soon, they are too coarse. You arrive to the coast, you arrive far away from the coast, first of all, with these global projections. So you know the sea level way out in the sea, and you have to carry it on the coast. Fine, you can do that, but the value that you get is uniform, you will see. And it's not true, it cannot be uniform, right? So regional projections, it means a lot of digital infrastructures, HPC, cloud computing, cloud analysis, and AI. This is the last machine learning, artificial intelligence now. So, but also we find that the European countries vary in their understanding of sea level science. Okay, let's try to, okay, now we got to the data. Now this is the data. We start in 1992, actually it's 1993, because the first 6 months we throw away. And this is the mean sea level. When you take all this data from the satellite and you take a mean, you get this trend. It is clearly evident, okay, what we are doing. But what is even more important is for understanding that there are bumps you see along. It's not a line. These bumps, we found out what they were. They were natural phenomena like El Nino. So they changed the global sea level. So we have to be careful when we see these changes together with the natural. El Nino is a natural event that happens in the tropical Pacific Ocean. And the redistribution of water vapor over land defined this big jump, the two jumps there. Okay, so what do? The trend is from 1999 to 2024. This is the most recent one. In the assessment report, we arrive at 2022, but I wanted to put this one, is 3.7. In the assessment report, you find already 3.2, because we are already growing from 22 to 24. 3.7 millimeter per year. So it means if you take the straight line, that in 10 years, it will be 3 centimeter per year. Oh, that's 3 centimeter. In 100 years will be 30 centimeter, and this is global. It means that somewhere it will be 1 meter, and some other areas will be lower. Okay, so this is a measure. Okay, that's what we give now. This is instead the map. And I have one which I took out for you. So what we see here is the trend every point on the Earth. Okay, so that the satellite sees. So it is again millimeter per year, and it's 10 millimeter per year. That's pretty large. And is also 1 centimeter per year. And here is 2.5. You see how non-uniform is. And I have this one for you. I have a zoom, you know? So now you start to see, you know, that there is a difference here and in the open ocean here. Now, if you ask me if I trust this, I say, not so much. I need a regional projection. I need a regional interpolation, or downscaling is called, in order to believe this. But it's already an indication. And it indicates how different is the sea level. For example, here in the Mediterranean, we even have a negative one in front of Crete. If you go to Crete, they are very happy now that they see this, you know, so, yeah. Okay, so, and now we're good for the future. The future is all uniform. I told you that. So, right, all of a sudden, you have uniform. This is the model. That's not a good model, right? Because the data before was very non-uniform. Now everything is becoming uniform. Because the models are not good enough, you need to get more. And I'll show you what we are preparing to get more. So sea level rise looks for impacts. So we looked at coastal and compound flooding. For example, one typical important part is you get precipitation anomalies, and you get sea level for different causes. So when the two are together, then you get an extreme event. This is called compound flooding. Okay, coastal erosion, very important. Saltwater intrusion. So people have said that after we study sea level rise, we need to look at this impact, because these are the ones that really we care about. So here is what we have in Europe. Not very visible, unfortunately. This is the picture of the report. So here is the shoreline retreat. You have shoreline retreat here. And this is done for the worst scenario. Okay, so this is the worst greenhouse gases scenario where you have no mitigation. And also, there is land loss. And you see, maybe you have not so much, but here, we're getting really bad. So again, this is in 2100, and so our work is to make this more and more precise. It is said it's not yet completely accurate. Okay, saltwater intrusion. That's a very important one, in my opinion, because drinking water depends on saltwater intrusion. Very important. So here you see, in Ireland, you have some points, and these are measured saltwater intrusions. So what is the cause of that saltwater intrusion? We cannot say sea level rise, right? But we have a saltwater intrusion. And people, when they use their models to look at this, they say sea level rise will help to get saltwater intrusion. Okay. So last but not least, what are the adaptation efforts across Europe? The strategies have been mapped in the report. There are mainly 4. The accommodation, changes in infrastructures existing, making more efficient and so on. Protection, advancement, and retreat. So the shift in strategy out of this report, which was mainly a literature report, so it's not a survey of any kind, it's a literature report. We have emphasis on combining engineering, what are called the gray solutions. These are the gray solutions, you see. We like a lot in Italy to do them. The one is the top. So you put big barriers, big stones. Engineer solution with nature-based approaches. And involving the community and adaptive management. Okay, so to go next, in this, we mapped 17 different adaptation measures. That's a very important point. And they were done for coastal flooding, for saltwater intrusion, etc. And the result is that accommodating measures are the first one to be undertaken, and followed by protective measures, and finally retreat, going away from the coast. Which is, in my opinion, really something that we should start thinking seriously for some areas. And most measures focus on avoiding coastal flooding and erosion. Coastal flooding is very important, so most measures are dedicated to that. Very little on ecosystems. We still to build everything there. And we really hope the young people will take the challenge. We need to look at ecosystem challenges. Governance. The challenge in governance for sea level rise is the time horizon and the uncertainties. How do you use the uncertainty with policymakers? Yeah. So cross-scale and cross-domain coordination, equity and social vulnerability, they show some cases. For example, this is a case that is in the report on the Ravenna municipality. They took a model, they worked with local engineers and scientists, and they defined 2 possibilities. One is the rigid one. You see these areas are done to cut the waves, to break the sea level, as they call it. And the other one, which is clearly preferred, the dynamic and evolutive approach, where you restore the marshes, you restore the natural environment. And clearly, who doesn't want to do this? The tourist economy that is very important in Italy and Europe. So we need to deal with that problem. Okay. So what is the plan of action now? Now that we have this, so in the UN Decade of Ocean Science for Sustainable Development that is running now, 2021-2030, this is our document, the science we need for the ocean we want. We have chosen, some of us have chosen to talk about transforming the monitoring and predicting. Let's see what I have now.
Globally, about 2 billion people live within 100 kilometers of the coast, and coasts are on the front lines of the climate crisis and other human-induced pressures. Rising sea levels, flooding, marine heat waves, extreme events, and pollution are increasing risks to the lives and livelihoods of coastal communities and the survival of coastal ecosystems. Solutions must be built with local needs at the center and be globally scalable to provide reliable tools for policymakers, managers, communities, and their economies worldwide. CoastPredict, a program of UNESCO Intergovernmental Oceanographic Commission's Global Ocean Observing System and the UN Ocean Decade, is leading a transformation in how we observe and forecast the global coastal ocean to provide science-based services and solutions for coastal resilience. At the heart of the program is the Global Coast Network. Through the global network of over 130 pilot sites involving more than 70 countries, CoastPredict is co-developing solutions in partnership with coastal stakeholders that will directly serve community needs, from risk management to climate adaptation. CoastPredict solutions integrate cost-effective sensors, satellites, cloud platforms, and AI-driven digital twins to deliver accurate, accessible, and actionable coastal predictions, multi-hazard early warning systems, and planning and visualization tools, even in regions that are currently data scarce. By combining scientific excellence with innovation, citizen science, and trusted public-private partnerships, CoastPredict is closing critical data and knowledge gaps and delivering tailored, region-ready solutions. From local to global, CoastPredict is building the knowledge and services needed to ensure resilient coastal communities, now and for the future.
This is one of the major programs of the UN Decade, which has already developed in the past 5 years the strategy to implement this in all so many coastal areas. What is the challenge? That normally science does not work that way. Science works a bit top-down, right? You first do something, and then you apply it one place, be sure that works in that place, and then you go to the next, maybe. In the coast, normally you don't. You stay there, and you refine and refine. Now, we're trying to instead get a generalizable system. And so we put together all the coast using the same system. And it's a big experiment, clearly. If we can do what we call the upscaling, this will be the first time it is done in science. Normally, you do downscaling. Okay, so let's, I don't remember, yeah. So CoastPredict, it's one of them. There are others, right? This is the one I use to approach the issue of the resilient communities. So we want to integrate coastal observing and predicting systems, the validation, you remember. So if I don't put the observing together with my prediction, I will never trust my model, and especially a policy maker will never trust it. So now we have something exceptional. So models can go from the open ocean, global, to the coastal area. This is an example. And this is the one that will allow us to have so many sites interconnected. So this is the progressive refinement. It's an engineering concept that is very useful for us, that we want to follow. Progressive refinement. You see the big flow coming from the open ocean. Now it's becoming a bit more complicated until it arrives here. This is the Taranto, is a big town in the southern part of Italy. And you see the colors are the intensity of the currents. And how can we do anything in management without knowing that? It's impossible, right? It's really impossible. And now it is possible because we have these digital tools that allow us to go from the open ocean, and for sea level will be the same. So, but most important, this is what I dedicate most of my time now, is to get much more observations, to trust the models, and to correct the models. And so here you see we have the so-called citizen science that is going to help us. Meteorology has already that, right? Has airplanes collecting data that are used in their model. Every airplane along their wings have sensors, transmit data in real time to ECMWF, the European Center for Medium Range Weather Forecast, and corrects the model so the next day the forecast is more accurate. We need to do the same in the ocean, on the coast in particular. So we are engaging with people for leisure boating. They can send us the data. Fisheries, fishermen, very important. Actually, they are the most engaged community of all. Okay, so I'll show you an example of, my small experiment on citizen science and what it can do. The 5th of October, we had a meteor tsunami in our Rimini. This is the Rock Island. Is a nice pub that is also offers a lot of meeting place. And we put a station here. And the data are visible for the people in the place. And so the 5th of October, they got a big inundation. All of a sudden, the sea came in. And this is what is a meteor tsunami. And our station was measuring the pressure drop, which is that one up there, pressione, it's written in Italian, pressione, pressure, and the sea level. You see the sea level got rapidly, in 2 hours, became twice as big as the tidal maximum. Now we know it's somehow a simple meteor tsunami. So the last mile is also these digital twins, and I conclude, I'm close to, so for adaptation planning. We have models now can allow, and AI and machine learning that allow us to ask questions like this. Are seagrass meadows capable of attenuating waves? We lost a lot of our seagrass in the Mediterranean. we had prairies of this beautiful plant that it can be 20 centimeter high or 1 meter high. And it's very well known, the Posidonia oceanica for the Mediterranean. It's a very important species, and we ask, we lost them, but we lost them because of the trawling, the fishing, okay? So we asked them, can we use the meadows, the seagrass, to alleviate the waves, to decrease the waves? And you see the two time series. The blue is when you have no vegetation, and the red is when you have vegetation. Big decrease, a big decrease for this area in Italy. And we can do this all over the world if we have the plan, as we said, the 150 areas where we will try this same method. Okay. So this is the network. And the big effort is to connect. You have at least in Ireland, I think there are at least 5 pilot sites that are in the network, in the global network. They work together in the network to discuss their solutions. And we hope young people will join as much as possible these discussions. So the key word is connect, have the collective intelligence, connect the global coastal ocean, and systematic, in order to carry out a comparison of solution and services, find robust science-based products, and compare and contrast. It's a big challenge, but the decade can do that, and we have a plan. At least we have a plan, right? Don't know if we can do it all, but the whole science community came together to have this plan. It's not a common thing. So then, in conclusion, I hope I have shown you that we have huge climate change impacts at the coast, and they will affect our well-being, but we are acting. We are active. So coastal resilience is difficult because it requires a multidisciplinary, multi-stakeholder approach. And to embrace this, we need to work in big groups. And in Europe and the UN Ocean Decade, I'm happy to say, have started decisively to take action with the support of the science community. And we still have 5 years, and I hope to see you sometime in the next 5 years. I have somebody else to tell you how did we do. Thank you.